Alright, so today we talked about the law of cosines, and we did a pretty challenging proof. Probably the most challenging yet, but combining some of the skills we used with the law of sines proof in the area of a triangle. I'm not going to go over that proof, but from it we end up getting the law of cosines. And the law of cosines formula I will go over. Core problems we looked at was 106 through 109. Really 106 and 107, and in the flip book we did the law of cosines, so that's what I'm going to go over right now. This will go in section 1.3 of your flip book at the bottom, the law of cosines. And again, this is for non-right triangles, so we don't have that right angle in there. Sketch out a non-right triangle. And go ahead and label these sides. C and angles. Again, the opposite sides and angles correspond to each other with the same letter. So we derive the law of cosines formula, which will look like this from our proof. C squared equals a squared plus b squared minus 2ab cosine of c. And there's some different parts to this. So some of you notice that in the front of the expression there's something that looks like the Pythagorean theorem. This formula is actually based off the Pythagorean theorem. The latter half of it, the minus 2ab cosine c, just helps us to accommodate for triangles that aren't that are not right triangles. So this minus 2ab cosine c, some of you probably recognize that that looks like the area formula for a non-right triangle, 1/2 ab sine of c. So if we go back to our triangle, ABC, I'll go ahead and circle these, A, B, and C, you have your side, angle, side. That's that relationship again. So that's what you're looking for here. Side, angle, side. That will help you identify what is C, what is A, and what is B. The other thing to notice, and this is what I try to remind my students of, is the only common letter in this triangle is C, angle C, and side C, which are at the front of the equation, side C, and at the end. In our triangle, that's what you're dealing with, the two C's. They are opposite or across from each other, and that's going to help us think about how to set the equation up. Instead of just memorizing the equation, it's important to understand what the letters represent in the triangle, and that it's just really a relationship between sides and angles. It doesn't really matter what A and B are, but C has to be opposite each other. Okay. All right, we're going to do an example that uses this formula. Start on a new slide. You can do this right below. Say example. So on your quiz, all I'll ask you to do is to solve, or on your test, solve the triangle. And this is going to be called triangle SUN, or triangle sun. CPM likes to jazz it up a little bit. All solving the triangle means is you need to find all the missing sides and angles. Go ahead and draw this out. Oops. say this is N, this is S, and this is U. And I know that this opposite side is 12, this is 8, and 6. So we do know 3 of the sides, but we don't know any of the angles. So we can't use law of sines, because law of sines you need at least one angle. So we don't have any angles. So we're left to using the law of cosines, which is c squared. Write it in again. C squared equals a squared plus b squared minus 2ab cosine of c. So we'll begin by using the law of cosines. Now we can solve for any angle at the beginning. I want to end up, let's just start with angle U. So we'll begin solving for angle U. Now, if we are solving for angle U, you want to identify what's opposite, right? So we have U and 12. So that is going to be my C's. They're across from each other, C and C. So here's how I'm going to set it up. We'll set up the outside first, and then we'll work our way in. So C squared is our side lengths. It's going to be 12 squared equals blank, all of this, of cosine of U, because that's the letter we're using. Remember, these are what's on the outside, 12 and U. And then the rest we can just fill in. A squared, blank squared, plus blank squared minus 2 blank blank. Alright, so we know that my other sides are 6 and 8. It does not matter what order you put them in. You're just filling in the blanks, 6 and 8. So now we can go ahead and work out the math. 44, 16, 128. Cosine of U. Alright, common mistake. Students want to combine these. Can't do it because of the cosine U. So instead we have to move the 100 over to the other side. So subtract 100 from both sides. Now we have 44 equals negative 128 cosine of U. Next move, go ahead and divide by negative 128, negative 128. And now we have this fraction, which I want you to leave like this, negative 44 over 128 equals cosine of U. And now you have to get rid of the cosine. And the only way to do that is back to the inverse. And the inverse of cosine is cosine inverse, which you can see on your calculator as cosine negative 1. You're going to take cosine negative 1 of both sides. We'll cancel this. And make sure you're in degrees. U will equal 110 point, or round to the nearest tenth, 110.1 degrees. Okay, so that's how to find U. Now that we know that U is 110.1, we need to find the other angles. Now, we could use the law of cosines again, but since we have one of our angles, it will actually be helpful, it'll be easier for us if we just use the law of sines. We're going to move into the law of sines now. Okay, So for the law of sines, let's go ahead and solve for letter N. And since we know one of our ratios here, opposite sides, we have 12 and u, we can start there. So we'll start with sine of 101, actually 110.1 degrees divided by 12 is equal to sine. Now we can solve for, we're solving for n, so it'll be sine of n, and the opposite side of n is 8. That's back to what we did last week. Go ahead and cross multiply. You're left with 8 sine 110.1 equals 12 sine of n. Now divide by 12 on each side. Divide by 12. We can put this whole thing in our calculator. 8 sine 10. To get the exact answer, you end up getting for this 0.626 equals sine of n. But you got to get rid of that sine, so we're going to again take the inverse sine. Take the inverse sine of both sides, sine -1 and sine -1 cancels, and n, if we round to the nearest tenth, will equal 38.8 degrees. And box that. So now we have u and n. The last angle, we could use the law of sines again, but since we know both of our other angles, we can just add them up. 38.8 plus 110.1, 148.9, and then we can subtract from 180. And for angle S, after subtracting, you find that angle S is 31.1 degrees. Okay, so you can see here a couple different steps in the process. We had to use the law of sines first because we had side, side, side. There was no angle given to us. After we had one angle, we could use two sides and an angle. So we could say side, angle, side to use law of sines. And then for the last part, we just subtracted from 180. And there's a lot of work involved here on the quiz and on the test. I will not tell you which formula to use. All I'll tell you is to solve the triangle. So it's up to you to create the process. Hope this helps.